Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. Today we're going to be talking about how to find the inverse of a function. So let me show you what I'm talking about and how we can do this. So first you start with some function, like let's say f of x equals the square root of 2x minus 4. And I want to find f inverse of x, which they usually write like this with the minus 1 power. Now that minus 1 power does not mean minus 1 power, it means the inverse of f of x. It also does not mean this. This is very bad, don't do this. Just write it like this. So anyways, all you gotta do is first replace f of x with like a y. Y equals root 2x minus 4. And then we are going to switch the x and the y so that now it's x equals square root of 2y minus 4. And now your goal is to solve for your new y. And so if I want to do that, I got to first get rid of the square root. The only way to get rid of a square root in math is to square both sides. So then that means we have x squared on the left, and on the right, the square root and the squared cancels, giving you 2y minus 4. Then if I want to solve for y, I'm going to add 4 to both sides. So I have x squared plus 4 equals 2y. And then finally, I divide both sides by 2. Now there's two ways you can write this. One is x squared plus 4 over 2. This is 100% correct. Or the other way you can write it is x squared over 2 plus 4 over 2, which can be written nicer as 1/2 x squared plus 2. Now I don't care if you write it like this, or even if you want to write it like this would be correct as well. Any three of these are perfectly fine, but at the end, you have to write f inverse of x equals one of these three. I'll choose 1/2 x squared plus 2, because that's the one I prefer. And that's basically it. You found the inverse of the function. One more time, here's what the original function looked like. Square root of 2x minus 4. And if I were to graph this in Desmos to show you what both functions looked like, 2x minus 4 here, and then the inverse, which we said was 1/2 x squared plus 2. It's gonna look like this. Let me zoom out a bit so you can see it well. And first of all, you notice this is kind of a weird example, and that's because the square root only exists for half the function, and obviously this parabola exists for both halves, the left and the right side. So if I do want to make this better looking for the inverse, I would give a domain restriction where x can only be greater than or equal to 0 because, well, I'm not going to get into why it's 0 in this video. It is not 0 every time. It has to do with properties of inverse functions. But the one thing I do want you to notice is that it is perfectly symmetrical along the line y equals x, which is what all inverse functions have in common. And so do you need to know how to graph this? No. Do you need to know how to do the domain restriction? Probably not. But what is important is that you know how to find the inverse by switching the x and y first, and then solving for y, and just calling it f inverse at the very end. So with that, we're going to do a couple examples today, and then we'll be done. So the first example I have is f of x equals 1/3 x plus 1. I encourage you to give this one a try on your own, with switching the x and the y, and then solving for y, and that should be your answer. So go ahead, pause the video, and when you're ready to see the solution, unpause it. Okay, so here's what I'm going to do. First, I like to rewrite it as y equals 1/3 x plus 1. Then I will switch the x and the y like this. And now the goal is to solve for y. That means subtracting 1 from both sides first, so it's x minus 1 equals 1/3 y. And if I want to get rid of this 1/3, I have to multiply both sides by 3. I can distribute the 3 if I want. That would be 3x minus 3 equals y. And that's basically my answer, except I would write f inverse of x equals 3x minus 3. And now we're done. And that's it. So hopefully you got that one right. If not, we have another example. This one's going to be g of x equals quantity x plus 2 squared minus 6. And as a piece of advice for you for this one, don't write f inverse as the final answer. Your final answer will be g inverse like this. And that's what you're solving for. But go ahead, give this one a try. And when you're ready to see the solution, unpause the video. Okay, so here's what I'm going to say for this one. First, just as before, y equals x plus 2 quantity squared minus 6. Then I switch the x and the y like this. And now I need to solve for y. So that's going to involve adding 6 to both sides. X plus 6 equals y plus 2 quantity squared. Now some people out there, they will try and FOIL the y plus 2. And if you do that, you're a fool. You will never get the right answer. So don't do that. Instead, all you got to do is take the square root of both sides. And in this case, on the right side, you get y plus 2 because the square root and the squared cancels. And on the left, you have square root of x plus 6. Now, if you're good at algebra, you'll know that whenever you take a square root, you should take plus or minus. And maybe your teacher will ask you to do that. But I'm going to tell you for this video, just keep the positive version. We technically can't have plus or minus when there's an x under the square root. You're supposed to write it as two different functions, like positive root x plus 6 and negative root x plus 6. But that's too complicated for this video, so I'm not going to go into that. And now, still solving for y, I'm just subtracting 2 from both sides, so that my final answer is y equals, well, really, g inverse of x equals root x plus 6 minus 2. And that's our answer. And no, you cannot simplify this anymore. And if you try to, you're probably doing something wrong. And so that's it. That's all the examples I have for this video. Thank you all for watching. I hope you have a great rest of your day. And I'll see you in the next video. Take care, and bye-bye.